Hello. In this video, we're going to generate an exact graph of the function -2 times x minus 1 squared plus 5. We're going to do this by following a step-by-step procedure and applying transformations to the x and y coordinates of the parent function. The first thing we want to do in this case is identify what the parent function is. We can identify the parent function by looking for this squared term. We actually know that this function is a quadratic in what's called vertex form. And it's called vertex form because we can read the vertex directly from this. We know the vertex of this function is going to be at 1, 5. At this level, all our functions are quadratics. But the reason why we stress this picking out the parent function is because what you're learning now will be applicable to other types of graphs later on. So next, what we want to do is state in words the transformations that are going to occur. And we can do this very easily by working from left to right and looking at the various numeric values. Just a reminder, the general form is for a quadratic in vertex form is f of x equals a x minus k squared plus h, and where a is our vertical stretch and h is our vertical shift. Notice the a and the h would be applied after the squared, which we call our parent operation. And that's how we know that those values are going to affect our y position. The minus k is going to affect the value before the parent operation, which is squared. So we know k is a horizontal shift. And remember that horizontal shifts lie. So the first thing we want to do is state in words the transformations that are going to be applied here. So the first one, we see we have a negative value here. The negative value is going to be a reflection across the x-axis. The second transformation, which corresponds to the 2, is going to be a vertical stretch by 2. The minus 1 is going to correspond to a shift. And what I do here is I actually use the word left or right as opposed to horizontal. And I'm going to say this is going to be a shift. And if it's minus 1, it's going to be a shift to the right 1. And finally, the plus 5 is going to be a shift up 5. So these are the transformations in words, and now we want to think about them in terms of what we have to do to each value mathematically. So when we reflect across the x-axis, that's like multiplying every y value by -1. When we have a vertical stretch by 2, that's like multiplying every y value by 2. When we shift right 1, that's like taking every x value and adding 1. Notice how it's lying. And finally, when we shift up by 5, that's like taking every y value and adding 5 to it. So now what we're going to do is use these transformations and apply them to our parent graph to figure out what this function looks like. So, to help out, I'm going to start by graphing the parent function, which is x squared. So we know we have the point 0, 0, 1, 1, 2, 4, and those are the only points that fit nicely on this grid, so we do that. And we know this is a symmetrical function, so what we sometimes do is we go over 1, over 1, over 2, over 2, and then we have the same nice smooth curve. So in order to apply these transformations, what we're going to do is we're going to apply them to each point in turn. And a little trick I like to do to kind of reduce the amount of work and allow for a check is I only do half of the parabola, and then I use the symmetrical argument to find the other half. So I always start with the vertex, which is at 0, 0, because the vertex is a very important point with a parabola. I'm also going to transform the point 1, 1, and I'm going to transform the point 2, 4. And I do this in two stages. The first stage is going to be the reflections and shifts. Sorry, pardon me. The first stage is going to be the reflections and stretches, and the second stage is going to be the shifts. And I help notate this by saying up here, this is going to be reflections 1 and 2 are first done. And then I'm going to end up design, then I'm going to do reflections 3 and 4. Sorry, not reflections, transformations 3 and 4. So I'm going to take the y value in each of these cases and multiply it by -1 and by 2. So 0, 0 stays as 0, 0. 0 times -1 is 0. 0 times -1 times 2 is 0. 1 times -1 is -1. -1 times 2 is -2. So this goes to 1, -2. 4 times -1 is -4. 4 times -4 times 2 is -8. So this goes to 2, -8. This is thought of as an intermediate step in between my parent graph and my final graph. And sometimes we might graph this. So if I underline this step in blue, I can graph this and see this as an intermediate step. So we have 0, 0 still on there. We have 1, -2. And we have 2, -8, which is way down there. So if I now connect this, I'm just going to have a nice smooth curve. And I'm going to be sure not to pass the line x equals 2, because we know it's not until we're down to 2, sorry, the point 2, -8's on there. Now again, I don't have this side of the curve, but again, we know the axis of symmetry passes through the vertex, so we can go over 1 to get that point there. And it's the same type of behavior, so I just have to make sure I don't pass -2. And there's my intermediate step. Now I'm going to apply transformations 3 and 4. So I'm going to take each x value and add 1, and each y value and add 5. So this becomes 1, 5. This becomes 2, 3. And 2 plus 1 becomes 3. And -8 plus 5 becomes -3. And so now what I'm going to do is I'll underline this and say, let's go with pink, shall we? And now I'm going to say the point 1, 5. So 1, 5 is right there. And then I have the point 2, 3, which is right here. And then I have the point 3, -3, which is right here. And then I just draw my nice smooth curve. And then again, the axis of symmetry cuts right down through the vertex, so I can draw that in. And I go over 1, over 1. Over 2, over, oh, pardon me, not over 1 there, over 2, over 2. And there is the graph of that function. Now a final step that's nice to do here is the check I suggested you could do is, we figured out this point by using the symmetrical argument. So what I could do is, this is the function at 0, so I could plug 0 back into f of x and ensure that I do get 3. And with your analysis of this function, which we did previously, you will see that that is the case. A last point. One way to speed up this process is to eventually get to the point where you can take each point and do these transformations directly on the graph. So let's use this point. I'm first going to do the reflection and stretch, which is going to take -1, 1 to -1, -2, and then I'm going to shift it 1 unit to the right, and then I'm going to shift it up 5. 1, 2, 3, 4, 5. And there's my check. I hope that helped.